So we've had a couple of videos on lines, slope, and the slope-intercept form of a line. In this video, we're going to get into more real-life applications, and we're going to talk about interpreting slope. What does it mean in a real-life graph when we have, actual data, a line that goes through them, and those numbers have meaning? Okay, so our objective: interpret slope as an average rate of change in applied situations. So again, we know that slope is how steep a line is, and another way to define it is the average rate of change, which we're going to focus on here. Slope is a fraction equal to the change in the height divided by the change in the horizontal distance. And in mathematics, slope is represented by the letter m. Okay, so what is a rate? If we're going to talk about the average rate of change, what is a rate? A rate is a comparison of two related quantities. Often, when you're dealing with rates, the second quantity is time, seconds, hours, etc. However, it can be anything. The average rate of change means per one unit. If it's time, for example, per second, per year. If it's another unit, something else, it could be, for example, per mile. Okay, so an average rate of change is talking about per one unit. As we talk about slope, that means we're going to have a 1 in our denominator, per 1. Okay, again, slope being a fraction. Let's do some examples. Okay, example 1 here. We're going to be interpreting these. The graph below shows a car's value on the y-axis over time on the x-axis. And as you might imagine, a car's value tends to start off high. When you buy the car, you're paying a higher price for it. And over time, the value of your car decreases. Okay? The car has less and less value. If you go to sell it when it's 10 years old, you're not going to get the same amount of money as when you purchased it. Cars decrease in value in general. We want to find the slope of the line, and we want to write the slope as a rate of change. Well, in this case, the 2 points we have, the new car, the y-intercept is $1,800. So this says here the new car is worth $1,800. It's a pretty cheap new car. An example I pulled from the textbook. And after 6 years, this is saying that it's worth $0. Okay, that's pretty stark, but we'll go with it. And we're already told in this example what the slope-intercept form of the equation of this line is. Y is equal to negative 300 times x plus 800. So what's the slope? The slope is equal to negative 300. Okay, negative 300. Now we want to write that as as a rate of change. Well, let's remember, slope is a fraction. And this, I like to put the sign to the numerator, and writing negative 300 as a fraction means putting it over 1. Okay, so now let's interpret this. Let's write it as a rate of change, okay, as a rate of change. A $300 drop in value, that's the Y. $300 decrease in value per year, that's the X. We have years, and I'll put a dollar sign over here. We have dollars, so we have a $300 drop in the value per year. Okay, so write the slope as a rate of change. A $300 decrease, or I use the word drop, per year. Okay, that's what's happening here. As a rate of change, you're seeing a $300 decrease in the value per year of age. Okay, so the same thing for this next example, which we'll do it twice with both men and women here. Example 2, I need to pull up my calculator. I haven't done this in advance. The graph below shows the average age of first marriage in the United States. Find the slope of each line, men and women, and write each as a rate of change. Well, it looks like the men here is the top line. The women is the bottom line. Let's do the men first. Okay, so the men. The slope, change in y over change in x. And again, I like to start with the rightmost point and subtract the leftmost point. So 29.2 minus 23.2 divided by 45, the rightmost point's x value, minus 0. Okay, this turns out to be, well, let's see, I think this is 6. Let me just double check. 29.2 minus 23.2, better be 6. Yeah. So this is 6 over 45. Okay. But we want to write this as a rate of change, so we want this to be a slope where to have a 1 in the denominator. Okay, so I'm going to divide both numerator and denominator by 45 because I want a rate of change. I want a 1 in my denominator. So what is 6 divided by 45? And this is 0.13. Repeating, I'll write that as 0.13. Okay, so what is this telling us? Okay, the age, there's an increase of 0.13 years per year after 1970. Okay, so since 1970, there has been an increase in the age that men get married of 0.13 years per year. Okay, so let's say that. Let's write that as a rate of change. Since 1970, we have an increase of 0.13 years per year. Okay, now we have years in both of these, and that's okay. But it looks like that men have been getting older when they have their first marriage at a rate of 0.13 years per year after 1970. So we could also say this as 0.13 years older per year after 1970. A couple different ways of saying the same thing. The important thing is the rate of change we're looking for out of a 1. What's happened when we move 1 unit on the x-axis? Well, obviously we move 1 unit, we have an increase on the y-axis, so we have an increase of the 0.13 years or 0.13 years older when they have their first marriage per year after 1970. Now let's do the women, and we'll do the same thing, and we can see the same thing is happening with women. They're getting older. Since 1970, they're getting older, waiting longer to have getting older before they have their first marriage, if they have more than one, I guess. Okay, so the slope for women, same thing. Go a little bit higher here so you can see it. Same thing, the change in y over the change in x. Okay, I always go from the rightmost point, so the 27.1 y value, 20.8. Okay, x value, y value at the leftmost point, sorry about that. And then the change in x, rightmost value is 45, leftmost x value is 0. Okay, I need to do this with my calculator, 27.1 minus 20.8. So this is a 6.3, slightly greater than the men. And of course, 45 minus 0 is 45. So that's the slope, but we want to write that as a rate of change. It says right up here, so we want to have a 1 in our denominator. So we'll divide numerator and denominator both by 45. 45 divided by 45, of course, is 1. 6.3 divided by 45, and my calculator is 0.14. So it looks like they are increasing slightly, ever so slightly faster. Their age is increasing before their first marriage for women. Okay, so we can say the same kind of thing here. Again, writing it as a rate of change. It's 0.14 years older per year after 1970. Women are getting 0.14 years older when they first get married per year after 1970. 1971, they're a slight bit older. 1972, a slight bit older. But the key here is this per one, which in this case here is per year after 1970. So there you have it, a little bit of realistic stuff that talks about how do we interpret a line that applies to data. How do we interpret that slope?